How are you, grade 12? Hope you are fine and hope you had amazing holiday. In this term 3, we will continue some work from term 2 and we will continue our induced current. We studied in term 2 induced current, but in this term we will start from lesson 2, the application of induced current. Our objective today is I can relate Lenz law to induced EMF, and also the second objective, how I can explain the turn ratio in the transformer effect for the potential difference. Okay, so we'll go ahead for first just something like remind you about the induced current. What is the induced electromagnetic force? What is this electromagnetic force? Again, electromagnetic, by the name electromagnetic, it's consists of two parts. Electromagnetic. When we discover it together, the coil or the wire, when it will be a coil, will produce a magnetic field and will have a force, a strong force. This force, it's called induced electromagnetic force. And if you read together from here, the electromagnetic force, EMF, of a wire moving in a magnetic field depend on what? Depend on BLV. The formula, which you have it here in the screen, EMF, electromagnetic force, is equal B. What is B? Somebody remember what is B? B is a magnetic field. Okay. What about L? The length of the wire. Okay. What about L? B magnetic field. Sorry. L is the length. V is the velocity of the wire. Okay. And we can also sin theta. This is the angle which it will produce from the field. So I want to remember together, what does it mean for induced electromagnetic force? Induced electromagnetic force, it's equal BLV. What is B? B is a magnetic field. What is L? L is the length of the wire. What is V? Is the velocity of the wire. So now you have a good introduction to just remind you about the electromagnetic force. We will start our first objective. It's Lenz law. What is Lenz law? Lenz law, he discovered something easy, and we are always using in some application in our real life. What's Lenz he discovered? Lenz he discovered when there is a wire in a coil, it's producing a magnetic force. Yes or no? Yes, producing a magnetic force. And this magnetic force direction will be opposite side of the wire. If the wire moving like that, the magnetic force, it will move to up. So both will be against each other, which will produce a strong force. Okay, we can read here together Lenz law. What is the meaning of Lenz law? Lenz law is speaking about the moving charge in the moving wire experience a force from the magnetic field. صح? It will produce a magnetic field which is in opposite direction. Think about that. It's opposite direction of the wire movement. Don't forget about this formula. We will use it later to solve some problem. EMF equal BLV. Electromagnetic force equal 3. What is B? B is a magnetic field. What is L? Length of the wire. What is V? It's the velocity of the wire. Okay, we can also explain Lenz law with another way. Still, we are in our first objective, the relation between Lenz law and the electromagnetic force. Okay, what is another explanation of the Lenz law? Lenz law says what? Says the magnetic field produced by the induced current is what's the direction he have? He have a direction opposite to the original field. Again, if you will have a screw, and around this screw there is a wire. Around there is a screw, there is a wire moving down. This wire producing electromagnetic force. This force direction is up. So if the wire movement is down, the force is up, which can make strong force inside the screw. Okay. So this one is the biggest, or this is the famous connection between Lenz law and the electromagnetic force. So again, Lenz law is too much famous physicist, and he helped us a lot in our real life applications, and later we will study how we can use that in generator, in microwaves, and so on. And this force, electromagnetic force, when it's produced, we use it a lot in our real life application. Now we are not depending only about electric force or a magnetic force. Both together, this two force, electromagnetic force, it's too much important in our real life. Again, what is Lenz law? Lenz law explains the direction of the current of the coil of the wire when a magnet is inserted into it, and the current produced by induced electromagnetic force. Somebody remember what does it mean of EMF? Electromagnetic force. What is the formula of EMF? The formula is BLV. Induced sorry for this late, I think some loading. The induced field exerts repelling force in the approaching magnets. This force which will produce a strong magnetic force. Thank you, and this one will speak only in this part about this relationship between the Lenz and the electromagnetic force. Thank you, see you later.